Part G, chapter number 2. In the previous class, we have seen why we need Venn diagrams to represent the sets, and also we have done activity to shade the areas. That one was very important because we are going to use the idea in next parts. This lesson we are going to do that shade area, but with the numbers. And here also we are not considering all the elements in our sets. Instead, we will just indicate it with the numbers, how many elements I have in my sets. So let's explain this topic by solving some problems from your exercises. So question number 1, as you can see, now in example number 1, what these numbers mean. These 8 and 6 and 3, 6 means intersection of x and y. You have 6 elements in the intersection area. Set x has how many elements? 14 elements. And set y, how many elements does it have? 9. And our universal set, how many elements do you have? In order to find, you just need to add all the numbers. So I have 19 elements. 19 elements. So let's try to answer this each part. In part A, what do we have? X complement. How many elements I have in X complement means beyond the X. In X normal I have 14 elements, and in universal I have 19. So total number of elements will be 5. Part B, we already had discussed this one. Intersection will be the number of elements. How many? It shows 6. And C, the union. For the union, you just need to add all these 3 numbers. Number of X union Y will be 17. Part D, X but not Y. So only X. In only X, we have only 8 elements. E, Y but not X, you have 3 elements here. And for F, neither X nor Y. So beyond their union. When you see this statement, neither X nor Y, means A union B, complement of the A union B. So it's only 2 elements. The next problem here is about the showing. Instead of numbers, we have letters here. Again, the idea is same. A union B. Let's try to check these numbers. A union B, as we have said in the previous lesson, in the previous problem, sorry. What do we need to do? Just add the numbers A plus B plus C. And number of A will be A plus B elements. Number of B elements in set B, B plus C. And the number of their intersection will be just B. And the right hand side we already had seen is A plus B plus C. Let's check whether this statement A is correct or not. The left hand side will be A plus B plus C. Is it equal to the right hand side? Number of A will be A plus B plus B plus C and minus intersection B. And the right hand side 1B will cancel each other, and I will have A plus B plus C, and on the left hand side also the same expression. So as you can see, this one is correct. For the second one, I will leave it for you to do it. Question number 7, what does it say? Now, universal set has 50 elements. I have set S 30 elements, set R 25 elements, their unit 48. Now, a lot of statements. Let's try to picture it. Let's draw the universal set as a rectangle, and I have 2 sets, and let me use circles for them. Let B set S, as they must have intersection. Why? Because union. Okay. Let me write the intersection like this. Let's try to put it universal set. This one let me be S, and this one is R. I have in union 48 and total universal 50. So I have 2 elements outside. And also look at here. When I add these up, the two sets, how many elements it will be? 55. But their union is 48. Now when I add them, my 50, it's more than their union, means that I have counted some elements twice. So how many elements they are? I just need to subtract these two statements. 55 minus 48, it will give me 7. So these 7 I counted twice is actually the intersection point. I have 7 elements in intersection area. So if it's 7, I already have in S 30 elements. Only in S will be 23. And only in R it will be 18. Now based on the graph, now let's try to answer the questions. What does it say? Intersection of number of elements in their intersection. We already had seen it, 7. And in part B, the number of elements in S but not R, which gives us 23.